Assuming you put it where the Sun is, it would relax to the orbit of Jupiter, a beast absolutely insecure and going to detonate. Among the most noticeable effects of radio energy in the universe, it conveys more energy than a billion suns. Bug-Jew or Betelgeuse is a red giant star. If you put it where the Sun is, it would stretch to the orbit of Jupiter, immense, totally erratic, and likewise poised to detonate. When we consider stars, we often envision insignificant twinkling things in the night sky. This is how we perceive them from Earth, but stars are entirely different. Among them, one of the most prominent is Betelgeuse, significantly more massive than our Sun. For years this star has puzzled astronomers, but recent findings have revealed something even more disturbing. Join us as we explore the remarkable new information about Betelgeuse, its impending destruction as observed by the James Webb Space Telescope, JWST, and how this cosmic event could influence our universe and our lives on Earth. A star of immense proportions. Betelgeuse is a colossal wonder, a massive star that has intrigued astronomers for centuries. A Greek astronomer named Antonius was the first to record it. This star is so gigantic that it can be observed in the night sky from Earth, especially during winter. If you're into astronomy, you've likely heard of this star. The reddish-orange hue marks the upper left shoulder of the Orion constellation. Despite being one of the most marvelous stars in the night sky, Betelgeuse's brilliance doesn't remain constant, it varies. This variability is a defining characteristic, but it isn't the only one. Let's delve into some of Betelgeuse's unique properties. Distance and size. Most stars in the night sky are far from Earth. The closest star, Proxima Centauri, is 4.2 light-years away. To understand this, imagine traveling at the speed of light, 186,000 miles per second, for an entire year, covering nearly 6 trillion miles. This is 1 light-year. Thus, Proxima Centauri is over 25 trillion miles away. Betelgeuse, however, is much farther, located roughly 600 light-years from Earth. If one could travel at the speed of light, it would still take 600 years to reach it. Despite its vast distance, Betelgeuse shines brightly in the night sky due to its extraordinary size and luminosity. The star is hundreds of times larger than the Sun in radius. If placed at the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, and even Jupiter. Its mass is estimated to be 12-19 times that of the Sun. Brightness and variability. Betelgeuse is exceptionally bright, its magnitude fluctuating from 0 to 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude 1 star. This brightness changes due to its pulsations, periodic expansions, and contractions caused by internal cycles. When it expands, Betelgeuse becomes brighter. When it contracts, it dims. These pulsations can last 10,100 days or longer. Its surface temperature, around 3,500 Kelvin, gives Betelgeuse its distinct red hue. Interestingly, it wasn't always red. About 100,000 years ago, it was yellowish like the Sun. Over time, it shifted to orange-red and then to its current red color, indicating its advanced stage in stellar evolution. End of life and potential supernova. Betelgeuse is nearing the end of its life. Having exhausted the hydrogen in its core, it now fuses heavier elements, expanding further. Eventually, it will explode in a supernova, a cataclysmic event releasing immense energy and scattering elements like iron and nickel into space. This supernova, visible from Earth without a telescope, would be one of the brightest celestial events in recorded history. It could occur within the next 100,000 years, a blink in cosmic terms, but predicting the exact timing is challenging. Insights from the James Webb Space Telescope. The James Webb Space Telescope, JWST, has provided unprecedented insights into Betelgeuse's behavior. Its infrared capabilities have revealed irregularities in the star's brightness and instability, confirming it is in its final stages. These observations shed light on the processes leading to a star's death, deepening our understanding of stellar evolution. Legacy and cosmic impact. When Betelgeuse goes supernova, its shockwaves might trigger the formation of new stars in the surrounding region. The heavy elements released will enrich the interstellar medium, contributing to future planetary systems. While its destruction marks the end of one star, it symbolizes the continuation of cosmic cycles. Studying stars like Betelgeuse offers valuable insights into the universe's dynamics, helping us understand our place within it. As we unravel the mysteries of these cosmic giants, we are reminded of the universe's vastness and complexity. The role of supernovae in the universe. Supernovae like the one Betelgeuse will eventually undergo play a critical role in shaping the cosmos. These stellar explosions are responsible for producing and dispersing many of the heavy elements found in the universe today, including those that make up planet stars and even living organisms. For example, elements like iron in our blood and calcium in our bones were forged in the cores of ancient stars and scattered across the cosmos during supernova explosions. When Betelgeuse finally meets its end, it will contribute to this ongoing process of cosmic recycling. The explosion will send shockwaves through nearby interstellar clouds, compressing gas and dust, which may eventually lead to the formation of new stars and planets. This cycle of destruction and creation is one of the most fascinating aspects of the universe. Could Betelgeuse's supernova impact Earth? While Betelgeuse's supernova would be a spectacular sight, scientists agree it would not pose a direct threat to Earth. At a distance of 600 light-years, the energy from the explosion would dissipate enough to prevent harm. However, the supernova would be so bright that it could rival the full moon in luminosity and remain visible in the daytime for weeks or even months. This unprecedented event would provide astronomers with a wealth of data to study the mechanics of supernovae, the formation of neutron stars or black holes, and the impact of such explosions on surrounding space. What happens after the explosion? The aftermath of Betelgeuse's supernova will depend on the star's remaining mass. If the core is above a certain threshold, roughly 2.53 times the mass of the Sun, it may collapse into a black hole. Otherwise, it could form a neutron star, a dense city-sized remnant made mostly of neutrons. Regardless of the outcome, the surrounding region of space will be transformed. The materials ejected during the explosion will mix with interstellar gas and dust, potentially giving rise to nebulae, vast, colorful clouds of gas that could become star-forming regions. The broader implications of Betelgeuse's death. Betelgeuse's demise will have broader implications for the study of stellar evolution. Observing its supernova will help refine models of how stars live and die, particularly massive stars. It will also improve our understanding of how supernovae influence galactic ecosystems and contribute to the chemical enrichment of the universe. Astronomers are already using data from instruments like the James Webb Space Telescope and Hubble Space Telescope to monitor changes in Betelgeuse's brightness and activity. By studying these fluctuations, scientists hope to learn more about the prelude to a supernova, which remains one of the most elusive phenomena in astrophysics.